immediately because we had a small, delay. Security Fuckups 2020, so which will be brought to you by Hetty. Hetty is living in Vienna. He's paid for destroying stuff, so you can see he's IT security guy and a geek, and he's also one of the core members of MetaLab, which is a hackspace. In his free time, he's at CCC camp or Congress, and he's also part of the Chaos Computer Club chapter in Vienna. And sometimes he's also playing Capture the Flag. At the weekends with his team, We Own You. So there will be a lot of stuff, because maybe you see in 2020 we've learned a lot of stuff about security. And if you say that security is having no unaccepted risk, we've seen that there's a lot of risks in the health factor. We've learned to manage risk and to think about risks. So
Let's go to IT security. There are three elements. The CIA is not only the American Secret Service, it's a fundamental aspect.
Okay, hi from the translation. There seems to have been a problem, a technical problem, and we just disappeared. Sorry for that. So we'll continue from now. So, okay, Hetty explained some basic security stuff, especially the CIA tried, but fortunately those are in English anyway, so most likely we'll have some idea. So now he's talking about command injection via manipulated cookies. So you can just change a cookie. And this was especially CV 2020-6364, and so you could manipulate the server and change part system critical data in this SAP. So it got the CVSS score of 10.0, which means a totally critical security vulnerability. Information about that was like the temporary fix was please just deactivate the systems and wait until a patch is there. So it was so bad. So you see that's a like really catastrophic mistake, which actually shouldn't be possible to happen. But humans have make mistakes, and so this can happen. So now we're looking at DOS, a denial of service, which just means that the service is denied, for example, by making a lot of requests simultaneously. So on against one server, and the server is no longer able to handle all those requests and just got stuck. And then you can have DDoS, so which is a distributed denial of service attack, which is the same thing, but just you have many computers making many requests and not just one computer making many requests. This can not only be by requests from a server, but it can also be by vulnerability, so that when you send some special command, the service will just die. So that is possible as well. Backdoors. Maybe you've heard of that. It's just it's a door. It's a possibility to just bypass authentication. It can be like fixed password, default password. It can be weak algorithms. It can be a hidden web page where you have to know the URL to access it. So there are different methods how you can exploit a backdoor. The most common thing is just a hard-coded password, and if you know this password, you can log in without knowing any account data. You just have to know this one password. A good example for that was the NSA backdoor of Juniper, so it's a bit older. That was a cryptographic backdoor. It was approximately like 2008 to 2015. It was in Juniper devices. It was a cryptographic backdoor, so it was an error. It was if they changed some parameters in the crypto so that all connections could be decrypted. But currently, what is new about that is that there was actually a second country which exploited this vulnerability. The NSA did it, yes. That's something we know already, but now that actually a second state also used this vulnerability and used those backdoors. The interesting thing about the report is that the NSA made a lessons learned about that, but they cannot find the document where this actually was written down, which is pretty absurd. I'm not sure if they actually have it, but just don't tell anyone. Or maybe it's, yeah. Well, another thing is authentication bypass. So it's just, bypassing authentication. By, for example, accessing special files where you don't need any login data. There are several different ways depending on the specific vulnerability in the device. Or just a broken mechanism. You can just use a simple password. One more thing is like, the loss of data. So there are two. The one is, oh, what a nice archive, which isn't available, or the other one, 404 backup or can't be found. Let's start with all of the voters in Israel, registry of Israel voters. So you can already see that in English. So the call revealed all usernames and passwords of system admins allowing one log so you could log in and download all of the whole registry. So yeah, so you actually got like the admin passwords, which is pretty bad. So of course the complete registry of voters of Israel was leaked, which is like really catastrophic. So what does it tell us? Don't use digital voting. Use pen and paper. That's the good thing to go. So next thing was perfect hacking tool was Windows Explorer. So it's just like your file manager in Windows. So there's a car sharing, a car renting company which is called Buchbinder. And they had a backup server which was totally open via the SMB protocol on 4.4.5. You didn't need a password, you just had to know the IP address. And so you could get the data of 3 million people. So the password, one of the bad things were actually in clear text, no hashing, nothing. And it was 10 years of data and approximately 10 terabyte, so which could be found there. The person who found this tried to contact Buchbinder for 2 months, and they didn't react anyway. So then they went to a German IT newspaper, which is called Heise, and only when Heise went to them and said, guys, there's something wrong with your SMB, wrong, and yeah, only when Heise contacted them, there's been. I haven't found any further information what happened afterwards. So because that's clearly a GDPR problem. So I didn't find anything if there has been any fines being paid. Last thing I know is that some lawyers try to find customers who want to make a class action suit against them, but I didn't find any more details if there has been any final. Yeah. Another thing is okay. Okay, so there was an Emotet attack against the court in Berlin. So there was the forensic report on that was actually published. Yeah, they were attacked by Emotet. Emotet is a pretty well-known spam contributor, or spam virus kind of thing. So what they say that should, and the report mentioned, which was published, that actually the whole Windows domain should be reset up completely new to make sure that nothing of the old weaknesses continues to exist. And they also said their antivirus totally failed because the malware was actually known, and the networks. But there was no network segmentation and there were no good logs. So, however, we don't know if if they had very bad, if they just configured their antivirus badly or whatever. They had McAfee, but it just didn't find Emotet. So that there was no network segmentation. That was also really bad for them and really good for the malware, and there were also no good logs, so they couldn't find out what actually happened exactly. So it was very hard to find out what happened and which machines are actually affected. So that was also a catastrophe about that. So they really had to set up the whole thing totally new. A lot of data was lost. So especially for a court, this is really problematic. I think they also do terrorist cases, so that's pretty bad when they lose all their data. Well, about this whole thing about data loss. So we have GDPR fines. Of course, we have this. Um, and some companies actually got like huge fines for that. And I hope this motivates other companies to do good data security and practice good data security, because these are in many cases sensitive data which is definitely not meant for the public. You can clearly do a lot of stuff. You can do a lot of identity theft. You can register accounts under someone else's name. So with this data, you can really do a lot of bad things. Responsible disclosure, that's the next thing. What is that? So it's just a process how you can tell any company that you find a mistake or a vulnerability in one of their software. So you give them a certain time span and tell them, yeah, so now you have this amount of time to fix it, and if you don't fix it until then, we will publish the vulnerability anyway. Some of them, like for example, Google's Project Zero, they give 90 days for device manufacturers, and after 90 days, they will publish their vulnerabilities, no matter whether it was actually fixed or not. Some people think that this is bad, some think it's good. I think this deadline thing is good, because in that case, you can pressure the manufacturers to actually fix something. Of course, it doesn't work out all the time, but I generally think the concept is good to pressure them a bit. Of course, that doesn't happen if it's just Chinese manufacturer which just manufacture something one time and never update it anyway. But for bigger manufacturers like Google or Microsoft, they are clearly motivated to patch stuff if they get notice of it. RCE, remote code execution. So this means that you can run your own code or programs on a remote target. So for example, on another computer, I could execute my code and start any program I'd like without anyone else doing anything for that at this different computer. So I have complete control of this other machine. A very well-known example this year was a Citrix Nextscaler, which was called Citrix CVE 2019-1978 something, I think. So it was a path traversal vulnerability, so you could access paths on a computer you shouldn't actually do, so which is rather trivial to find and exploit. You can also patch it rather easily, but people didn't do it. And the really problem is that this is a very enterprisey software. It was used by a lot of governments, huge companies and stuff. And the worst thing about that was that it led to a remote code execution. So there was pretty quickly there was a public exploit which was available on GitHub. So really any bad guy could use that. And just try it everywhere, and you load malware on those computers. So if you don't actually patch this immediately, you can think this system is compromised. And after even days later, there have been reports about unpatched vulnerabilities. So actually, this thing was really patched already in 2019, but the exploits were published at the beginning of 2020, and only then people started patching at all. And it was pretty hard to find out if you're compromised, how badly you're compromised, if you have to reset up your whole system. So that was really a very bad release. Man, do you like receiving emails? By now, I really don't like getting emails. They're bad alternatives, but of course, emails are there, and we have to work with emails. So, and again, at the beginning of the year, there was something great with emails. Or let's say, not that great actually. Open BSD's mail server open and SMTPD. There was an exploit via email, so you could it was also remote code execution via email, but it was restricted to 64 characters. The email. So, but you could even circumvent this limitation. And so, for example, the Morris worm did this similarly. You just executed the body. So in the body, you could put a shell script and send this as mail, and so programs didn't understand that, and just execute that. And so this is how you could, circumvent this 64 character restriction. So this led to having you could run your own code on this email server just by sending an email there, which is also rather catastrophic. Well, but it happens. Humans write code and humans make errors. Well, POC, proof of concept. What is a proof of concept? That is, in general, it's just a proof that you were able to exploit a vulnerability. So the classical one is that you let a calculator appear. So you start a calculator program on Windows. That's just a classic example of how you do that. Other things, other possible things are possible, of course, but on the Windows, that's like the standard thing to do. Haha, I can now run a calculator on your computer, which shows that I can start programs and execute code on your computer. You could also create like an account, which you shouldn't be able to, or delete some data. So there are really like a lot of different possibilities for this proof of concept, but that's the classic thing to do. To demonstrate that you have execution rights. So, of course, hi, can I have a demo? So all of the last years I had a demo. This year, unfortunately, I had a lot to do. I wanted to do a live demo, but unfortunately, time came, and so because of time constraints, I don't have a live demo here, but I have demo videos with me where you can see nice things. So next time I'll have a live demo myself. Now let's talk about crypto. Cryptography is of course very complicated, and errors in implementation can really have huge problems for confidentiality. So if you do errors there, the cryptography isn't safe anymore, and so the ciphertext can be decrypted, or it hasn't even been encrypted really. So implementations have to be tested, and by now you also use like mathematical proofs to show that your crypto implementation is good, and they're trying to do real mathematical validations and verifications that this is true. But in general, crypto is hard. It's not trivial, it's easy to make mistakes, and if you forget whatever, or like using too small values for something, it happens unfortunately very often, and that the implementation of cryptographic algorithms are wrong or flawed. So some examples, crypto leaks. So there was a crypto company called Crypto AG, a company in Switzerland. They sold like devices which made hardware encryption, but over 20 years there was kind of like an open secret kind of thing that they have something to do with secrets. And then last year, or in 2020, it was found out that some journalists received proof that this company was actually created and owned by the BND and the CIA between 1970 and 1993. Then the BND, so the German Secret Service, stopped, but the CIA continued to use it until 1993 and after 1993. So those secret services were involved in the company and backdoored the cryptography, and so all the communication which were done by this hardware, they could actually decrypt and read the contents in plain text. They sold this crypto hardware to a lot of governments and countries of other states. and those states used it and thought this was secure, so they used sensitive calls over this, like with embassies, with other partners. So, but the BND and the CIA could actually decrypt most of the data that was sent via those devices. You could actually see it in this graphics, in this meme. Yeah. So they had the company, they decrypted their data, and they even sold this stuff to the different countries, but still they could read everything, all the sensitive data. So that's kind of, yeah. But now, no fun at all, no more fun. So BND and CIA knew about human rights violation. They knew about murder. They didn't do anything against that. And one of the employees of this company was already almost 1 year at arrest, but he did but he didn't know anything about that. So then he was fired. This employee was fired. So he thought that the people who actually arrested him knew more than he did about the company for which he worked. Because he started asking strange, started asking questions after that. Yeah. But then at the end, it turned out that they were right, and this employee, yeah. Zero logon, a new vulnerability that was in August 2020. We just have a weak cryptographic algorithm. And you could just spoof to be any account against, so you needed any account as a DC, so the domain controller, where all the accounts of the company are managed, all the PCs are managed, so like it's the central point of any company using Microsoft Windows and Active Directory. And if you had any account details for this DC, you can't reset or change the password of this account. Actually, you could change the password of the computer password of the domain controller, and so you could actually, hijack the whole the domain controller, and by that you can hijack the whole Active Directory of the company. So it got a CVSS score again 10 of 10, so as critically as it gets. So those domain controllers are usually not exposed to the public internet, but only accessible via the private network. So, but as soon as any attacker is in the internal network and they know the address of this internal DC, they have they just won. So they have complete control over the whole network. So any attacker in your network with this vulnerability, they can just compromise your whole network, because they can compromise your central server, and they can change everything and take over everything. Yeah, so that was a really bad thing to happen. It was just a vulnerability in the implementation, and that was the catastrophic result in that. So, okay, let's talk about hardware security. Yeah, we don't only have software, we also have hardware, which should be secure as well. Let's start with CD Pawn. So there's a demo video, I promise. That's a whole bunch of vulnerabilities in Cisco's proprietary discovery protocol. So there were 5 0 days published, which is 4 remote code executions and 1 denial of service. So 0 day is a vulnerability which is published before it has been patched. So yeah, okay. Now he says again 5 of them, 4 RCs and 1 DOS. So there are a lot of devices affected: switches, routers, IP telephones, and firewalls. And now let's see a video from an IP phone takeover that was done. That video is from the company which actually found the vulnerabilities. So. Okay. Okay, so you can read the subtitles in the video anyway, so. Okay, so now they downloaded Doom onto the telephone and play Doom on the telephone. So, well, yeah, that's really bad. So they completely took over the phone and, yeah, can let the telephone play music, blink, and yeah, throw it out of the network. And as you see, so of course you could like also crash all the phones, so it was a really powerful security vulnerability. Yeah. No. So let's close that down again. So back to the presentation. Let's continue. Processors. Nice. So processors are everywhere, in your computer, in your car, in your washing machine. So my best guess would be just burn everything and rebuild it. Security is hard, but as soon as it's on silicon, you can hardly repair it. So it's a really difficult problem about processors. You just have to renew it. I mean, yeah, of course, that is what they are currently doing, but what has been broken before can't be like fixed now. BlueFrag was also one of the vulnerabilities of my favorites. It's a BlueFrag. It's a remote code execution without any user interaction. You just delete the MAC address and of the MAC address of the affected device, and Android 8 and 9 were affected. Thousands of devices will never get a patch, and the only workaround you can do is deactivate Bluetooth. That's it, nothing else. Unfortunately, very unfortunate, but this happens. And yeah, with some, so you buy them, you get 1 or 2 updates, and then nothing else happens. So, yeah, Mikko Hypponen, maybe some of you know. It's of course a Finnish guy, Hypponen from F-Secure. And he says his law is whenever an appliance is described as being smart, it is vulnerable. Hypponen. Well, so there's a very nice example for that one. Smart lock. So Luca Bongiorno analyzed a very cheap security smart lock. So the chip was locked. So there was no trivial way to just read out the firmware. So okay, but what about a physical check? Like physically check this smart lock. There's also a video about that. And well, so here you see how a setup of his attempt. So the chip is locked. He can't just read the firmware, which is good. But then you thought about, well, what about just doing a physical test? Let's play it. Physical test here. Okay, it's closed. You can see that. It just screwdriver, bit of bumping, and that's done. So what good is the software if the hardware is total crap? As you can see. As you can see, physical security or safety is also important, but then again, like really totally hardware security. So the internet depends on secure hardware, and there's for DNSSEC there's a root key, and they have to re-signed time and time again. So on those keys are in safes with thick walls, and in February there should be one of these ceremonies by the DNSSEC, but they had to delay that because the mechanism of the safe didn't open. It had an error, so the key wasn't accessible, and so they had to postpone this whole thing. So that was just a mechanical lock, which didn't work out. Another example is the Apple T2 security chip, which is also rather new. So it's an Apple security chip in their devices. And the problem is the vulnerability itself doesn't expose any sensitive data, so you just can't use this. But you can then introduce a keylogger and install a keylogger, and then it can log everything you put into your via your input devices and can store that somewhere. You have to have physical access to this computer or telephone to actually exploit this vulnerability. But the huge problem is it's hardware, it's not patchable. So it's in the read-only memory. If you just write it once, it can never be changed again. So they can now create new chips which fix this, but all of the old chips are affected and they can't be fixed. So as we said, as soon as it's on silicon, you can't like repair it because it's totally broken. So that's the problem in hardware security. Either you have perfect security from the beginning or it's broken and you can't do anything about it. Well, for 2018, my presumption was this one. And you see, yeah, you're running, but in 2020, the reality looked more like this. So even far worse than I expected, and it doesn't get better. Everything is broken. So Microsoft's products, whatever. So I still hope it's getting better, but my hopes unfortunately are pretty low. So, but we can stop with a good example, a positive example. So GitHub, for example, created, so if you put a private key by accident onto your GitHub account, GitHub will give you a message saying, excuse me, we think that you have a public key, a private key here, and so the key was blocked quickly and restricted. So GitHub just did this quickly because they just recognized, oh, this was a private key, please lock it down. And this can be automated by now, so but that's a good idea on how you can do security correctly. So, but it's automatically reported, and so it's not as bad. So, but many people ask, yeah, but what does that affect me? Well, of course, actually, this affects all of us. You use devices. And because you use computers, you use a car, so yeah. But what are the problems of IT security? So the problem is you have no or very slow response times from manufacturers. So either they don't report to error, either they don't respond to error reports, or they just take forever. Another thing is that you don't have any laws which force IT manufacturers to guarantee updates, security updates at least, for a certain amount of time. So that's why many manufacturers just don't care and don't do any security updates. Another thing, IT security, so sometimes if someone finds a vulnerability and tells the company try to sue the researchers and threaten them that they are going to sue them, despite the fact that researchers actually want to do something good, they are threatened by a law action. Of course, another thing is bad software quality in general. Bad software has a lot of bugs, and so you need quality assurance. Yeah, and one of the last things is defending is much harder than attacking in the IT space. So you just have to do one mistake and the defenders all have lost, but the attackers just have to find one mistake and they can try as often as they want. So what can I do as myself? So you can start educating your environment about IT security and problems about IT security. So use secure messages, stuff like that, and just educate your peer groups. Support your local NGOs like Epicenter Works, EFF, Privacy International, whatever. Use GDPR to and check your data. Use responsible disclosure, and also you implement privacy as by design. Here is some here are some security, so some advisable URLs you can read. And at the end of 2020, Adobe Flash will finally die, almost. But yeah, so thanks to my girlfriend, to my family and friends. Thanks. Stay safe and patch your systems. But now you can ask questions. At least I can't hear the moderator, so I don't know. Okay, but it seems like I can hear Hetty, but I can't hear. There seems to be a problem. Okay, so now, nice that I'm now unmuted. Many thanks to Hetty. Apart from the content, I like also from my job, I really think that you do a great work of explaining stuff to people, because those basic patterns are important to tell people. So thanks for that. The call to action was great. We also have two questions. Let's start with the smaller one. By someone who says they're a hacker newbie. How do you recognize hackers in your network? That's hard. Analyze logs and see if there are weird patterns. You don't actually think there are like many requests that computers, but it's not trivial. It's not an easy problem to see. Maybe that computers behave strangely, that accounts don't work, that new accounts appear. There are many ways. And just talk with colleagues, research it on the internet, but there's no quick question. Second question was a bit in the direction can't you be sued if you hack? So people who find vulnerabilities, sometimes you may have to access sensitive data to prove that you found a vulnerability. But is this not real hacking? So what was the basic questions? If you can't be sued, if you can be sued? Yeah. So does the possibility exist that you have to go to court if you? Yeah, of course. There are problems with the law, and of course they can actually take you to court. There are some NGOs who want to help you in that case. In many cases, this is a good idea. Yeah, just go to a local CERT, Computer Emergency Response Team. So those are like local IT security institutions for your country, and they will do the communication between you and the company. And so you tell them what you found, they will tell your company what you found without exposing you to who you are, to the company. And so you have a good. So is there any server operating system you use which has a lot of security features and which are activated by default? Hard question. I usually use Debian stable, sometimes Ubuntu server, but it really depends on what you want. There are better systems which have better security features, like OpenBSD, or which has jails. There's no this single one OS that is secure. Each of them have their pros and cons. Of course, I mean, some of them care more about security. Just read it up and try it out. That's important. One more question. You said you don't like to use email, and there are better alternatives. Which alternatives do you use to send messages? I use Threema, Matrix, because I really like Matrix as it's a federalized federal alternative where you can have your own servers, and which your server can. Well, email, you see, it won't go away. It's here. It won't. Maybe in 10 or 20 years we will get rid of emails. but it's unrepairably broken, I would really say use Matrix or use Signal for one-on-one chat, and this is at least the stuff I use. Okay, so all questions asked. Hetty, thanks for Security Fuckups 2020. I'm pretty sure in 2021 there will be some more. Oh yes, I'm waiting. Well, so we are done with this talk. Will there be, so yeah, okay, you can also join Hetty in the